This is a heat exchanger. This is actually an open example of that, and it's pulling that heat through. And while you actually have your air being pulled in on the return side of the house, and it's flowing over the heat exchanger, and that's what's heating your air. This one is an 80%. This one actually is a 90%, and it's got PVC ventilation. So it's a high efficient unit, and they actually use PVC to vent it out because you get condensation that develops in the pipes.
So when you say 80 to 90%, that's like how much heat is retained and not lost in the process? Or what does that mean?
That's the percentage, that's the efficiency rating of how much heat is actually transferred with the energy that's expended.
Gotcha.
So, you know, you can have 95% efficient. Once you get over 90, 92 is probably a decent percentage. But you know, there's not much difference between 92 and 95, and you're paying a lot more for the very high efficient models. So generally a 90 plus will do very well. Also what a 90 plus allows you to do in some of the older houses, if you upgrade the water heater and the furnace, it allows you to bypass the gas combustion chimney. And a lot of times on an older house, at some point you'll need to line that chimney with a stainless steel liner for the combustion because it's slowly broken down to clay tile, if there is clay tile in it, or the masonry that's in it. So one thing that this allows you to do is actually take the exhaust and vent it directly out the sidewall. There's another water heater, we don't have it on display, but it actually comes with an inducer fan that's on top of the water heater that's basically just like this. It spins around and it's drawing the exhaust gases and pushing them out. And that can also vent with the PVC. So if you have two appliances like that, this is a metal B-vent, but obviously you can have a masonry chimney that runs up, clay tile lining that. The exhaust gases would run through that. A lot of the older construction is actually, there were wood stoves that were feeding that.
Okay.
So you'll see chimneys in various rooms in, say, a home that was built in the 1900s. And those chimneys are typically not lined with clay. So somebody then takes a furnace and puts in the exhaust gases, and those exhaust gases are actually corrosive to the brick and the mortar. And they'll slowly break down that brick and mortar, and it starts falling, and it'll start falling in. And you'll see the joints on the outside get deteriorated and start breaking apart.
So you'll see that on the chimney?
You'll see that. So some people will come in and actually rebuild the top part of the chimney. We'll come in and we'll see clay tile coming up and through, but we look down and the clay tile stops right at that top part because they didn't rebuild the whole thing. So that's where they come in and they'll sleeve in a liner through there and they'll make the connection within the chimney. So they'll basically install a B-vent within the chimney.
What is a B-vent?
This vent is actually a single ply vent, standard vent. This upper section that we see going in is a double ply vent, that's a B-vent. So the double ply is actually when you're running it through a wall. So you'd have the inner part will be hot to the touch. So if I were to have the heat on right now and I touch this, it would get burned.
Oh, okay. So it's like...
So if this is contacting any wood, any paper products, there's a chance of a fire.
Gotcha.
The B-vent dissipates that heat and eliminates the chance of any kind of contact that'll create a hazard. But let's go over the AC.
Oh, I'm sorry, I was just, so the heat exchange unit right there heats up the air, and then, and there's also a blower in there, so that blows
Yeah,
straight
there's a
up
blower
through
in there.
those coils and...
That's your blower motor underneath there. Let me actually hit that for you here. So right now, if I were to press the thermostat, kick up the temperature, first thing you would hear is the inducer fan start to cycle through. It's testing the system.
Mm-hmm.
You got the igniter going on, the gas kicks in, you'll hear the flame kick on. Once that heats up, the blower fan will kick in. And you're drawing in airflow. Typically you want to have it on varying levels. If you have supplies in the ceiling, you want to return down low, and that'll create your natural airflow. In this case, we have a return up top. That's great if you're on the second floor because that'll draw a little higher. And you have floor vents that will blow the cooler down low. It'll circulate the airflow. Now, right now, we have the heat on. Let's say we want to have your air conditioning come on. You have a couple different parts to your air conditioning. The part that we see inside here is called the A coil. It's actually the evaporator that we got right here. And there's a line on here, it's called the A coil line set that runs to an outside condensing unit. The condensing unit contains a compressor and a condenser on that. And there's a refrigerant that's in there. What that unit out there is doing is basically the compressor kicks in. Feel your ignition already?
Yeah.
The compressor kicks in, it's basically taking low pressure gas and it's compressing that gas and it's creating it into a high pressure unit. And it flows into from the compressor into the condenser where that condenser actually takes that gas and allows it to expand it and dissipates some of that heat, and it actually comes in off of this larger line as a cooler gas, under a little less pressure. It runs into the house, back into the A12 that we have over there, pushed through a very tiny hole that opens up and releases back into a fluid form. And that transition, when that gas is undergoing that process, is actually blowing air through that, helps the transition through that process, is actually extracting heat. And it's pulling heat out. It's not actually cooling. It's cooling it. When you go into a high-rise apartment building, you actually have something called right over that. And you're still getting condensation, and you're still getting the same effect, but the refrigerant is different. The refrigerant is actually pulling out your heat. So it's pulling out the heat, pulling out the humidity, and that's helping it undergo its processes, and then it returns back into your condensing unit out there where it undergoes the same process, cycles back through, and it's constantly going until it reaches the proper temperature that you have set inside your house.
Okay.
I don't know if that helps you out at all.
No, it doesn't. Never knew anything about it.
It's a little bit complicated, but basically your refrigerant is pulling your heat out very properly. This line, if there's humidity in the air, will be sweating. That's why they have insulation in it. So you're extracting the humidity from the inside of the structure and the heat, and you're transferring it via your condensing unit. And it's a two-part system, or really a three-part. Condenser, compressor within this unit, evaporator, coil within that unit. See what else we can cover here.
Another thing I want to point out is the AC has condensation in its drain.
It is.
Sometimes that drain gets clogged.
Sometimes we're talking about service issues. And sometimes what you
High
have,
efficiency furnaces and AC both need.
sometimes when you have an AC coming in, obviously the house, if you have a house that was built in the 20s or 30s, it wasn't designed or built with AC in mind. So somebody had to come in and create drainage for that air conditioning system now. So a lot of times when we come into a home, condo, we'll see a lot of creative work done with condensation. That trap dries out. So sewer gas comes right through. And then the idea is obviously sewer gas, could have bacteria, whatever it has in it. You have an A coil in there, it has condensation, so you could create something that possibly might be a breeding ground for.
Bacteria. Gross
Yeah.
stuff.
So where are you looking for it to drain?
We want it draining into a trap, a floor drain. So you can have a trap.